All right, we are going to be moving on to Chapter 4, and Chapter 4 is something we should know a lot about in Minnesota because we live in the land of 10,000 lakes. Lots of water here. Not the case for everywhere on Earth, definitely not even the case for everywhere in the United States. So a lot of times when we talk about these things, I think some of these concepts are kind of weird for us where we live, but remember we want to be thinking about globally, all of these things that we talk about in class. The global impact of all these things. So chapter 4 is all about water and the water cycle. And what we talk about first in the first section is essentially water on Earth's surface. So how water on Earth's surface is found, where it's found at, and essentially in what quantities those are found at also. So 4.1, water on Earth's surface. We are also called the water planet for a reason. Over 70% of Earth's surface is covered with water. 70%. When you think about that and you compare that even to the few planets that are in our solar system, we are the only one with liquid water on the surface. We have some evidence of some frozen water in other locations in the solar system, but we definitely have the market cornered on water. So 70% of Earth's surface is covered with water. And in my opinion, it's what really gives us its beautiful color there. And as we all know, we find water in lots of places. We find water in oceans, in rivers, in lakes, underground, as ice. We find it in the air. It's found in lots of different locations. So when you look at the distribution of this water on Earth, so we're covered by 70% of water, but now kind of look at how that's distributed. So of the total water volume, if we look at 100%, 96.5% is found in oceans, seas, and bays. So that would mean that it's salt water. So think about, can we even use salt water for drinking? Can we use it for bathing? No. So just even looking at that small part of it, that is locked up and we can't touch that. 1.74% is in ice caps, glaciers, and permanent snow. Can we use that? No, we cannot. So now when you start to look at what's the stuff that we can actually use for everything that we use it for, it is a really, really small amount of water. When you look at the total percentage of some of those other places that we find it, groundwater, lakes, in the atmosphere, rivers, really, really small compared to the amount of water that we actually have on Earth here. So overall, we do not have a lot of water available to us to use. And that's why it's really important to respect the water that we have and treat it as such so that we can use it for the things that we need it for. So water as a resource, the temperature range on Earth's surface is actually just right for water to exist. So when you look at our temperature range in degrees Celsius, minus 88 to 56 degrees Celsius, it's just right for liquid water. If you compare to the other inner planets in the solar system, Mercury is either too hot or too cold. Ranges anywhere from minus 170 to 390 degrees Celsius. Remember, water boils at 100 degrees Celsius, if that gives you an idea of the heat. Look at Venus, 45 to 480 degrees Celsius, same thing, water boils at 100 degrees Celsius. Think of that. So as soon as that water is there, it's going to go up into the air as water vapor. Mars is just too cold, so minus 89 to 20. We do have some evidence of water, especially on the poles at Mars, but it's in frozen form, but we don't have it in liquid form. So we have this thing, it's sometimes called the Goldilocks zone that Earth is found in, because we really are just right for temperature, for life to exist, and for liquid water to be on Earth's surface. All of this water that we've just talked about, water that's found in oceans, in rivers, in the air, all of that water is a part of what we call the hydrosphere. So the system of all the water on the Earth is the hydrosphere, hydro meaning water. So we find it in 3 different phases: solids, liquids, and gases. In solids, we're going to find it in ice or in glaciers. In liquids, we're going to find it in oceans, lakes, rivers, groundwater. And then in the atmosphere, as a gas, we call that water vapor. But all of that together, when you combine all of it, is what we call the hydrosphere, hydro meaning water. So cannot stress enough the amount of water that's available to us. So when you look at the pie graph in the upper left-hand corner there, that is all the water in the hydrosphere, 100% of it. So when you really start to break it down, only 2.8% would be fresh water. And then look at that 2.8%, 2.15 is locked up in ice form. So really, really a very small amount of water that's available for us for eating, drinking, industry, farming, all of those things. So places where water is found, so when we find it on Earth's surface, we call that water. So water that collects on the ground. So this would be lakes and rivers, places like that, that is surface water. So it includes oceans, lakes, rivers, streams, and then something that we call a reservoir. A reservoir isn't a term that we use a lot around here. It's definitely used more in the south, but it's a protected artificial or natural lake that is used to store water. So it's essentially a way for people to store water to be used for later on. And it's protected because if you're going to use that water for something else, you don't want people to be able to do anything they want with that water. Otherwise, you're not going to be able to have it for what you need it for, essentially. Glaciers, we're going to talk more about these later on this year, but we got to talk about them now because they are essentially solid water. So huge, massive ice that forms on land when snow and ice accumulate faster than they melt. So they're found in places where the climate is cold enough that it never gets warm enough to melt it in the summertime. So you just get this over a long period of time, this build up and build up and build up of ice, essentially. So most of Earth's fresh water is actually in the form of glacier ice. Glaciers are really cool. They play a really important role in the state of Minnesota, especially. We have had different periods of glaciation, and they have played a huge impact on shaping the surface of Minnesota and what our landscape looks like. Water will actually also collect underground, and that is what we call groundwater. So when you think of water landing on Earth's surface, it can also seep down into the ground, and that is called groundwater. So some of the water on Earth's surface moves down through the soil. So think of it kind of like seeping down into the soil. The upper level where we find that is called the water table. So the water table is the upper level of groundwater, and it's different depending upon where you are at and what your location is. For example, where I live, the water table is actually quite low. The other thing that can affect water tables is the weather. So if you're in periods of drought, when it's really hot outside, really dry, that water table is going to go down. If you're in periods of a lot of rain, that water table can go up. So don't think of the water table as something that's always in the exact same spot. It's going to move up and down. And it's also important to remember when we're talking about groundwater, we're often not talking about like a river that's flowing underground. Think of gravel that's full of water. So all spaces between the particles of soil and rock can be filled with groundwater. It's not necessarily like an open cave that you would see under the ground there. So one of the reasons why water is so useful is it dissolves many things. So it dissolves nutrients found in food, dissolves gases such as oxygen and minerals found in rocks. It just plays a really important role in essentially tons of things. So not only is it important in our body because all the processes that we have in our body have to do with water. Think of everything on Earth, plants that need water, growing crops, how industries, anytime we have a product that we purchase, water was usually involved. Doesn't even matter if it's the end product is water, water was used in making that product. So we're actually about 60 to 75% water, the human body is. So when you eat food, water in your body dissolves nutrients so they can be carried throughout your bloodstream, keeping you alive and healthy. So we have lots of uses for water. It's very necessary besides keeping us alive for agriculture and farming. So think about growing crops. Almost all of the food that you eat contains water or water was used to grow it. Even if we're talking about if you're eating meat, that meat needed crops that use water to grow it. That meat also needed water to keep that animal alive. For example, I think I remember hearing when you're talking about a cow, a pound of beef uses hundreds of gallons of water. So just to produce 1 pound of ground hamburger is hundreds of gallons of water. So it's also used, like I mentioned earlier, in industry and in your home. So water is really important for us, and that's why it's so important to treat it as a respectful resource. I think we're really lucky where we live. We kind of take that for granted in just how much water we have here. So really important on Earth.